Unsaturated hydrocarbons are hydrocarbons that have multiple bonds. Alkenes are hydrocarbons with at least one double bond. Alkynes are hydrocarbons with at least one triple bond. And aromatics have a very special type of bonding. The double bond in alkenes is shorter, stronger, and more reactive than a carbon-carbon single bond. The double bond is the reactive site in alkenes. Alkenes show up in many naturally occurring compounds. A large class of compounds known as terpenes have pleasant smelling or flavorful chemicals. Humulene is a terpene that has 3 double bonds and is found in hops, which are used for the brewing of beer. Myrcene is another terpene which is found in bayberry and some other medicinal plants. The carbon-carbon triple bond in alkynes is shorter, stronger, and more reactive than a double or single bond. Carbon-carbon triple bonds are so reactive that they are rarely encountered. Benzene, capital C subscript 6, capital H subscript 6, is the simplest aromatic compound. When we look at the Lewis structure of benzene, it appears that there are 3 double bonds and 3 single bonds. Actually, each bond is the same length and is longer than a double bond and shorter than a single bond. The 6 electrons that would be involved in the double bonds of the Lewis structure are actually delocalized among all 6 carbon atoms. This is an incredibly stable type of bonding and rarely seen outside of 6-membered rings. Aromatic rings are not very reactive. A hexagon with a circle in the middle stands for a benzene aromatic ring. The circle indicates the special type of bonding exhibited by aromatic molecules. If you ever open a pamphlet for a pharmaceutical product, the pamphlet will contain a molecular structure of the active ingredient. On the slide is the molecular structure for ibuprofen, and we can identify the aromatic functional group as well as the carboxylic acid functional group. The structure of epinephrine, the active ingredient in EpiPen, allows us to see the phenol group, which is a hydroxyl group bonded to an aromatic ring, the alcohol functional group, as well as an amine functional group. Organic compounds often have several different functional groups, and being able to identify the carbonyl and hydroxyl group will help you recognize and identify many other functional groups.